Now we will see question number 4. Question number 4 states that prove that a line drawn through the midpoint of one side of a triangle parallel to another bisects the third side. Okay, that means here what is the given value? That we have taken triangle ABC, DE parallel to BC, it is given. Second thing, that it is the midpoint, one side is the midpoint, that means AD is equals to DB, that means D is midpoint. Okay, that is the given value. Now what is required to prove here? We have to prove that it bisects the third side and we have to use basic proportionality theorem. That means we have to prove AE is equals to EC. Okay, now let us see how to prove it. We know that by using basic proportionality theorem, if a line is drawn parallel to one side of a triangle, then it divides the side into equal ratios. Therefore, in triangle ABC, as DE is parallel to BC, therefore AD by DB is equals to AE upon EC. Okay, using BPT or Thales theorem. Now AD and DB are equal. Why? Because in the question it is already given that it is the one side has the midpoint. We have taken D as a midpoint of AB. Therefore, as it is already given that D is midpoint, therefore AD is equals to DB. I can write AD by AD is equal to AE by EC. Okay. Now AD by AD will be cancelled and we will getting 1:1. Therefore, AD by AD is cancelled. The answer is 1 by 1 is equal to AE by EC. If I multiply EC here, EC is equal to AE. Therefore, as EC is equal to AE, that means E is the midpoint of AC, which is the thing we have to prove. That means E is the midpoint of AC. Okay, that is what we are asked to prove. Therefore, the proof here is of only 4 steps because we have been using basic proportionality theorem. Okay friends, let's move on to question number 5. Let us see question number 5 now. Here we have to prove that a line joining midpoints of any two sides of a triangle, that means a triangle ABC, the midpoints are D and E, we have to prove that the line formed by joining these midpoints is parallel to the third side. That means we have to prove D is parallel to BC using converse of BPT. Now, what is given in the question? That D is midpoint, D and E are midpoints of AB and AC. Therefore, AD is equal to DB and AE is equal to EC. It is given. Okay. Now we have to write required to prove. What we have to prove? That DE parallel to BC. Okay. Let's start the proof now. Now as we know that AD is equals to DB. If I divide both sides by DB, okay, then here it will be becoming 1. Now I will be getting DB by DB is equals to 1. This is my first equation. Similarly, if I taking AC by EC is equal to EC by EC, it will be cancelled. It will also be equals to 1. It is my second equation. Now from first and second equation, I have AD by DB is equals to 1 and AE by EC is also is equals to 1. Therefore, AD by DB is equal to AE by EC. When the ratios are equal, then the line formed by this triangle is parallel to the third side. Then we can say that DE is parallel to BC by using converse of BPT. Okay? So, what we are asked to prove that when midpoints of two sides are being joined, then the line formed by joining these midpoints is parallel to the third side. We have proved AD by DB is equals to AE by EC. That means the ratios are equal. If ratios are equal, then the lines are parallel. Then the line drawn from these two sides of which the ratios are equal is parallel to the line of the third side of the triangle. Therefore, DE is equals to BC. By using converse of BPT, we have proved this. Okay. So, hence proved. Okay. So, we will be seeing now sixth question. The question 6 states that in the given figure, DE parallel to OQ and DF parallel to OR, and we have to prove that EF is parallel to QR. Okay. So, given. What is given? DE parallel to OQ and DF parallel to OR. What we are required to prove here? We have to prove EF parallel to QR. Okay, let us start the proof. Let us take in triangle POQ. Okay, we are given that DE parallel to OQ. Therefore, using basic proportionality theorem. Okay, using basic proportionality theorem, PE by EQ is equal to PD by DO. Okay. Similarly, in triangle POR, we are given DF parallel to OR. Again, by using basic proportionality theorem, PF by FR is equal to PD by DO. Okay. So, let us give this equation 1 and this equation 2. Now, you can see in both the equations, PD by DO is common. As PD by DO is common, we can equate the values. Okay. Therefore, from equation 1 and 2, PD by DO is equal to PE by EQ is equal to PF by FR. Now, OB by BQ is equal to OC by CR. Now, OB by BQ is equal to OC by CR. Therefore, BC parallel to QR by converse of BPT. Okay. Hence proved, because we are asked to prove, we are here asked to prove that BC is parallel to QR, which is proved here. Okay. So now we will be moving on to question number 8.
Now let us see question number 8. Here ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect at a point O. We have to show that AO by BO is equal to CO by OD. Given value AB parallel to CD, required to prove AO by BO is equal to CO by OD. Now here we are constructing a line. I am writing here construction. We are constructing a line EF parallel to AB and DC EF. Therefore, I will be writing EF parallel to AB parallel to DC. We have constructed a line. Now we will take in triangle ADB. In triangle ADB, as the line EO is parallel to AB, EO parallel to AB, therefore ED upon EA is equal to DO by OB. Okay, by BPT. Similarly, in triangle ACD. Okay, ACD. AE by ED is equal to AO by OC. Okay, same by BPT. Now, let us give this equation 1 and this equation 2. By equation 1 and 2, we can see that ED by EA is equal to DO by OB, and here AE by ED is equal to AO by OC. So let's reverse this and we will be getting ED by AE is equal to OC by AO. Okay. Now here also ED by EA is equals to DO by OB is equals to DO by OB. Okay. Now what we have to prove? AO by BO is equal to CO by OD. Now we will take this part and we will take the inverse proportion or reciprocal. Then AO by OC is equal to BO by DO, and we will shift BO to this side. AO by OB is equal to OC by OD. So here is the required value which we have to prove. AO by OB is equal to CO by OD. Okay, hence proved. Now let us move on to question number 9. Okay, now the ninth question of 8.1 exercise. This is the last question. Let us see how to solve this. We have to draw a line segment of length 7.2 and divide it in ratio of 5:3, and we have to measure the two parts and verify the results. Okay, first we will draw a line of 7.2 centimeter. Now after that we have to divide it in the ratio of 5:3. That means total 8 parts we have to make. Therefore, make an acute angle of any measurement and measure 1 centimeter arc and divide this into 8 parts. 1, 2, 3, 4, 5, 6, 7 and 8. Okay. Let us assume A1, A2, A3, A4, A5, A6, A7 and A8. This is A and B. Now join this point to this. Okay. Now we have to take the ratio of 5:3. Therefore, first, second, third, fourth, fifth. Here again join to this. Therefore, this is the first part and this is the second part. Now 7.2 by 8 into 5. So it will be around 4.2 and 4.5, and the remaining value 4.5 plus 7.2 and 2.7. Okay, so the values will be 4.5 and 2.7. Okay, you have to draw this line parallel to this. Similarly, you have to construct, and when you measure, the values will be 4.5 and 2.7, which gives us 7.2. Therefore, the both values are verified. Okay, thank you.